my name is Tiana, and today I'm going to be teaching you how to use the unit circle. The unit circle and the trig ratios in that are very important for pre-calculus. Okay, so to start off, the unit circle is a circle that has axes. So this is the UV plane, which is a good thing to know. On the unit circle, it's made up of a bunch of different right triangles. Now, the right triangles that are most important are 45, 45, 90 and 30, 60, 90. Okay, well, my drawing is not that specific, but and then, okay, so each special right triangle has its own specific ratio that goes with it. For this 45, 45, 90 degree triangle, the most important ratio is a 1, 1, root 2 ratio. On the other side, the 30, 60, 90 has a 1, 2, root 3 ratio. Okay, so to go back to our circle, we have many of these special right triangles all together on this circle in different planes. So we have a 30 degree here, 45, and a 60 degree there. If we go even more, so this is going to be our 90 and our 0, we would hit a 220, or 120, sorry, then a 135, and a 150. And then this will be our 180. So, if this makes sense, from 0 to 180, these are all the points across the line. What we are trying to find is the trig ratios, the sine, cosine, and tangent, and the cosecant, the secant, and the cotangent that go with all these, and the easiest way to find those. So if you go back to our right triangle, our 30, 60, 90, so if we look here, this is a 30, 60, 90 triangle right here. And so if we're going to find the sine, if you remember SOHCAHTOA, so the sine here would be the opposite over the hypotenuse. Okay, and so we're going to be taking the opposite, which is 1, over the hypotenuse. So it would be 1/2, but the thing here is that your sine ratio is your y value. So you're going to be putting that here, and then to find your cosine ratio, you would be taking your adjacent over the hypotenuse. So then you would have root 3 over 2 as your cosine. The tangent is always going to be the sine over the cosine. So if we do the math here, multiply it by the reciprocal, and then it would become, which is also 1 over root 3, just so we understand where the tangent is. For your 90 degree triangle, because of the ratio, your 1 root 2, both the sine and the cosine will have the same values. So, but for this, you will be having a root 2 over 2 value. And then for your 60, as you might imagine, it's the same ratio as your 30, so your sine and your cosine will be switched. Okay, so now we have the sine and cosine for all three of these values, and now we need to know all the rest of the values around the rest of the unit circle. So what I came up with was a tool that helped to figure out how these values are all connected. So as you see here, the 30, 45, and 60 degree triangle, like lines, angles, are right here. And they also are color-coded by each degree. And around the rest of these axes are the rest of the degrees around the unit circle. So, for your 60, your reference angle, which is the angle from 0 here to your ray out here, is 60. If we go over to 120, the reference angle will also be 60. It's just going from 180 to 120 instead of 0 to 60. So, there's one very important thing to remember when dealing with the trig ratios on these axes, is that all students take calculus. This means that in this quadrant, the first quadrant, all of the ratios will be positive. In this quadrant, only the sine is positive, tangent, and cosine. So, if we go here to our 120, it's going to have the same values as your 60 degree, but only your sine will be positive. So, to demonstrate this idea, I have 10 different ratios to test out. The first is the sine of 60, which we already figured out. The second is the cosine of 225. So you see here, 225 is down here. It's in purple, so it will have the same as a 45, but it is in the third quadrant, so cosine will be negative. So this means that if we use our 45, the cosine will be root 2 over 2, and since it's negative, the cosine of 225 will be negative root 2 over 2. That one was Our next one is the sine of 300 degrees. If we go here, 300 is green, which means it's part of the 60 degree. It is in the fourth quadrant where cosine is positive, so this will be a negative value. We take our 60, so our sine will be root 3 over 2, so it will be a negative root 3 over 2. Okay. For our next one, we have tangent. As you might remember, tangent is the sine over the cosine. So if we go here to 315, it's purple, so we're using 45. So both values will be root 2 over 2. The cosine will be positive and the sine will be negative. So what we're going to do here is we're going to go negative root 2 over 2, and that's going to be divided by positive root 2 over 2. We'll end up with a negative 1 here. Okay. Number 5, we have the sine of negative 135. Now, when thinking about this, this is why I have the lines that are connecting to make these triangles, because if you go out here to 135, this angle, if you flip it over, you'll find the negative 135, which is the same as 225. So, to think about this, we will then think about the ratios that came with 135, but think about them in the third quadrant. So, let's see. Your sine value will be the same, and it will be a negative, because it's in the third quadrant, root 2 over 2. Don't get that mixed up with the regular 135, because the sine value in that quadrant is positive root 2 over 2. Okay. For our next one, we might have to do a bit of math, is the cosine of 540. So as you can see, this is over 360, which is right here. And so we would have to see 540 minus 360, and so then that's going to be 180, and okay, so if you go along here, go here, your cosine value is going to be a negative 1. This is because at 0 or 360, you are at 1, comma 0, because in the unit circle, the radius is 1, and you're on this axis, which is 0. So if we went over to 180, we would be at a negative 1, comma 0. So then that would be your cosine. Okay, the next one is a tangent of negative 450. So, if you had a positive 450, we would end up at 90. So what we're looking at is a negative 90 value, or negative 90 more than 360. And so if we went down here, it would be a 0, comma, negative 1. So this would be your value down here. And since it is sine over cosine, it would be undefined because you cannot divide something by 0. Okay. 3 more. So our next one is a secant value. It is the secant of 390. Okay, so if we go here and we think about our sine, cosine, and tangent ratios, they all have a ratio that goes with them. For sine we have cosecant, for cosine we have secant, and for tangent we have cotangent. So what these are the reciprocals of our sine, cosine, and tangent ratios. So secant here would be the reciprocal of our cosine. So we first have to find the cosine of 390. And so what we do is we would add and see how much more, which is 30. Go to our 30 and we would find our cosine value to be root 3 over 2. That means that if you take the reciprocal, it's going to be a 2 over root 3. That would be your secant value for 390. We'll also do an example with cosecant and cotangent. Our cosecant one is negative 120 degrees. So if we think back, we're going to go to 120, take our line down, and this will be our negative 120 value. If we take the sine of this value, it is negative root 3 over 2. And if we were going to take the reciprocal of that, it would end up being a 2 over root 3 as well. For our last example, we're going to use a cotangent, and it will be the cotangent of 210. If we go by, we find 210 right here. The ratios for 210 are negative root 3 over 2 and then a negative 1 over 2. To do this math, we would end up getting a 1 over 3, root 3, excuse me, and then to take the reciprocal of that, we would end up getting just a root 3. Now, this is a lot of information, and what I advised was just an easier way to remember exactly how to find which ratios go with which angle measure. So thank you for watching, and goodbye.